Hi gang, it's me again. In our last segment, I showed you how to convert a 5 grams percent sodium chloride solution into a milliosmolar solution. This time I want to tell you about converting glucose. We're going to start again with a 5 grams percent solution. And our goal is to figure out if this solution will be isoosmotic, hyperosmotic, or hypoosmotic to our normal body fluid osmolality of 280 to 300 milliosmolar. As with our previous segment, the first step is to write out the 5 grams percent as an actual mathematical term. Write it out. 5 grams percent means 5 grams in 100 milliliters. Step 2. Convert the grams percent to grams per liter. In order to do this, we simply multiply the 5 grams per 100 milliliters times there are 1,000 milliliters for every liter. The milliliter terms will cancel each other out, and we are left with 50 grams of glucose for every liter of solution. Step 3. Convert the grams per liter to moles per liter. We need the molecular weight of glucose in order to do this. Glucose is C6H12O6. If we take the atomic weights for all of these carbons, hydrogens, and oxygen atoms, we would get 180 grams for every mole of glucose. Using this number, we take our 50 grams per liter and multiply by every mole has 180 grams worth of mass. This leaves us with 0.28 moles per liter. For step 4, we now need to convert this molarity, moles per liter, to molality, which is moles per kilogram. In order to do that, we simply multiply our 0.28 moles per liter times, for every liter of water, it has a mass of 1 kilogram, and that gives us 0.28 moles per kilogram. Remember, this is a license we are taking in our class. You cannot do this in a chemistry class. It is only because we are dealing with water as our solvent and we are dealing with very dilute aqueous solutions that we can have this license of converting molarity to molality. They are close approximations to each other because we are using water. In step 5, we need to now convert the molality to osmolality. We need the dissociation factor for glucose to do this. Well, glucose does not break into 24 individual atoms. It does dissolve in water, but it does not dissociate. So we take our 0.28 moles per kilogram. We recognize that glucose will stay as one molecule, so we have 1 osmole for every mole of glucose, and that gives us a 0.28 osmole for every kilogram of solvent. In step 6, we need to convert this solution's osmolality to milliosmoles per kilogram so that we can compare our body fluid osmolalities. The normal is 280 to 300 milliosmolar. In order to do this, we simply multiply our 0.28 osmoles per kilogram times there are 1,000 milliosmoles for every 1 osmole, and that gives us a solution osmolality of 280 milliosmolars. Step 7. What would a human cell do if it were placed in this solution? Would it swell and take on water? Would it crenate and lose water? Or would it be happy and not have a net gain or loss of water? Well, 280 milliosmolar is just spot on to our normal body fluid osmolalities. This solution is isoosmotic as well as isotonic, and our cell will be very happy and not change volume.